Hey guys, so this is some of the notes. We're going to be working 14.1 through 14.2. We're actually going to do it in three phases, one for each of the different trig functions that we're going to learn how to graph. And so this first trig function we're going to learn would be something like y equals a times the sine of bx plus k. Now, not everything is going to show up in each problem. So I'm going to identify what everything is, and then we're going to say, okay, sometimes they'll look like this, sometimes they'll look like that, and we'll kind of go from there. So the first thing we need to talk about is this a over here. A is what we call our amplitude. Okay, so the amplitude, it tells me how high and low my graph is going to go. Okay, so that's the first thing we're going to talk about is amplitude. The next thing that we're going to talk about is this b value. Now, this is the multiplication by x. A lot of times it'll be 1. Sometimes it'll be a fraction. That's when you're looking at division instead of multiplication. So the rule that we want here, we talk about the period of the wave, or how long it takes for the wave to complete a cycle. And that period will always be 2 pi divided by b. Now again, sometimes b is a fraction and we'll have to do some flipping times. And then this last thing that we have over here is a vertical shift. If you see a +5, that means the whole graph has been shifted up 5. If you see a -2, then it's all been shifted down 2. So I'm going to go through a couple of examples, and hopefully as we finish these examples, it'll be enough for you to be able to produce the graph. The first thing that you need to understand about a sine wave is that if you start here at 0, 0, okay, the sine wave is going to go out 4 marks, usually out to, so I'm going to always choose to go out 4 marks to the right, and this 4th mark, whatever it is, we're going to label the period. Okay, so I'm going to start with the most basic wave I can. Y equals the sine of x. Okay, this is as simple as it can get. There's nothing else to it. And I'm using unit circle numbers to kind of help. So I'm going to kind of think about over here the unit circle and how it goes around. Okay. For instance, at 0 radians over here, the y value, which is my sine, is 0, which means I would have a dot at 0, 0. And then we're going to count all of these marks here on the axis as our 4 marks as we make our way back around to the beginning. This is what we mean by a cycle. It's going to repeat itself every time we go around the circle. Well, if we go 90 degrees, or pi over 2, that would be right up here. And up at the top of the circle, the y value is 1, which means I'd want to go up to 1, put a dot right above pi over 2. The next place I would go, okay, well, pi over 2, if I have 2 of those, that's the same as pi. Think of it as 180 degrees if you need to, but I'm trying to stay with the radian mode because that's what we're going to see on these graphs. Pi, well, over here we've got -1, 0. So we're back to having a y value of 0. Then if we go to 3 pi over 2, okay, down here we're at 0, -1, which means I'd come down here at -1, have a dot over here below my 3 pi over 2. And then my last spot would be returning back to where I'd started at 2 pi. And over here at 2 pi, I'd be back at 0. So you can start to see this wave occurring. And the really cool thing about the sine wave and all of these trigonometric waves is if I went out one more mark, okay, one more mark would be 1 more quarter, I'd be back up to 1. And then I'd come back to 0, down to -1, and back up again. And so you can see that this wave is going to repeat over and over again. What I'm going to ask you to do, okay, is actually produce the wave one to the right and one cycle to the left. So this would be negative 2 pi. And so this is really important. If we're going backwards instead of forwards, okay, my first spot would be to go to negative 1. And that should make sense because the wave is cyclical. It's going to repeat. And then I'd come back to 0, go up high, and back to there. This graph right here, that solid dot, the solid line with the marks labeled across here on the right, pi over 2, pi, 3 pi over 2, and 2 pi, that's what we're really after. I'm going to simplify your work a little bit for you in terms of what you're actually going to be asked to do, but this is the wave we're trying to produce. All right. So a couple of things that you're going to always need to be able to do is find the amplitude and find your period. Okay. So let's take a look at a couple of basic examples. Let's look at y equals 3 times the sine of 2x. Okay. This is a pretty straightforward one. You'll see a few of these at the beginning of the assignment. And it's a pretty good example of a test question. All right. First thing I want to do is figure out my amplitude. This is always pretty easy to find. Amplitude is just the number out here. So I'm going to go up to 3. I'm going to go down to negative 3. Okay. I know that the sine will always start right at 0. That's going to always happen for our sine. And then I am going to go out 4 marks either way. 1, 2, 3, 4. For a positive sine function, which I think most of these are. There might be some that are negative, and we'll talk about it in a second. But for a positive sine value, the next dot will be up at the amplitude, then back on the axis, then down at the negative amplitude, and back on the axis. So the graph to the right is going to look like this. And if I want to do it to the left, remember we go out 4 marks. I don't know what the period is yet. We'll get that in a second. But I'm going to go down, center, up, and back to center. And so that right there is my completed graph, except I still haven't labeled the period. I'm not going to make you label every mark, but I do want to know that you can find the 4th mark. And so to find this 4th mark, what we do is we always go and find the period. We're going to take 2 pi, and we're going to divide it by whatever number is multiplied by x. In this case, it's a 2. Well, 2 pi over 2 should simplify to just pi, which means I can label this mark as pi and this mark as negative pi. That right there is all I'm going to ask you to do for graphing 3 times the sine of 2x. I need to know what the period is, which is my 4th mark, and I need to see the general curve with the amplitude done correctly. Let's look at another example or two. If you feel like you get it after this next one, you're probably good to go. But I do want to talk about the what about this and what about that, some of the problems that can come up. So let's take a look at y equals sine of x over 2 plus 5. Okay. So when I go to graph this, first thing you might notice is that there's no amplitude. Well, there is an amplitude, it's just not written. The amplitude is going to equal 1 on this problem down here. Okay? And so you might say, oh, I'm going to go up 1. And that would mostly be right, but there's a problem. See, the vertical shift of 5 means that the center line actually belongs up at 5. So I'm actually going to go 1, 2, 3, 4, 5 to my vertical shift, and I'm going to draw a horizontal dotted line. It's not an asymptote. We're going to call this a midline or a center line. Everything is centered around that mark. So instead of being centered here at 0, 0, I'm going to be centered at 0, 5. Okay, so you can kind of see that dot there. Then from there, I will measure my amplitude. My amplitude will go up to 6 and down to 4. 1 unit from my center line. Okay, so that's pretty straightforward. I'm still going to go out 4 marks. Yes, I'm going to label the marks down here. I know you're probably focused on them up there, but we're going to label them. Go ahead and just put them down here. And then let's grab a different color. We're going to go from this center dot. It's a positive sign, so the first mark will be up at its amplitude, then back to the center line, then down to its lower amplitude, and back to the center line to create a curve that should look like this. And I can do the same thing going backwards here, center, up, center, and we get that curve to continue both directions. We're golden, except we still haven't done the period. The reason I wanted to look at this problem is the period is supposed to be 2 pi over the number multiplied by x. Whenever you have x or theta over something, you have to think of it as 1/2 x instead of x over 2, or 1/3 x instead of x over 3. What that means is I'm going to have a 1/2 in the denominator, which if we keep switch flip means we times by 2 over 1, and that should give me 4 pi. So my period here is actually 4 pi, which means that, the first mark will be 1 pi, then 2 pi, 3 pi. You're more than welcome to label all of them. In pre-calculus next year, if you take that, you're definitely going to have to. But because of the distance learning, let's just make sure we get the basics down. All right, the last thing that we should really make sure you're aware of is what does happen if it comes out negative. And so I just want to graph this last one, y equals negative sine of, let's say, 3x. We'll just call that good. My amplitude here is still 1, but it is negative as an equation. So it's going to affect the way I graph this. I'm going to go out 1, 2, 3, 4. 1, 2, 3, 4. Instead of going up to my first amplitude, I am going to go down because it's negative. Then back to the center, then up, and then back down. It should look like an upside down version of what we were graphing earlier. So again, that'll come up, then down, and then back up. And there's my sine wave when it's negative. Now when it comes to finding the period, again, it's 2 pi divided by whatever is next to x, multiplied by x, that is. So that's 3. So I would label this end 2 pi over 3 and negative 2 pi over 3. All right, I hope that that's enough to get you through the sines. Now remember, there will be another video for cosine and another video for tangent. My recommendation is go and graph each type one at a time. Make sure you're really comfortable with each type. Good luck, and we'll see you in class sometime.